Hello everyone, my name is Chloe and I am a second year PhD student funded by NUC, located at UCL and King College London with a case partnership at the World Conservation Monitoring Centre. Thank you for taking the time to come along and listen to my talk on how we can assess the effectiveness of terrestrial protected areas. And in this talk, I wanted to give you some background on my project and how I've started preparing for the analysis of my data. Protected areas can be very useful as they are a globally recognised means of conserving nature. The largest global dataset on protected areas is the World Database of Protected Areas, the WDPA, which is put together by the United Nations Environment Programme and the International Union for Conservation of Nature. And this is managed by UNEP WCMC. Protected areas that are added to this database must fall into the two definitions listed on the screen, as stated in the user manual for the World Database of Protected Areas and the World Database on Other Effective Area-Based Conservation Measures, otherwise known as OECMs. This database is made available via the Protected Planet website, and it's updated monthly and is free for all to access. There are many reasons why we might want to create a protected area, and broadly they can be broken down into intrinsic and utilitarian arguments. The Aichi targets set by the Convention on Biological Diversity, the CBD, ensure that affording protection to the natural world are made part of legislation. And it was stated in Target 11 of these Aichi targets that by 2020, at least 17% of terrestrial and inland water areas should be afforded protection. And according to the Protected Planet website, which has the most comprehensive global list of protected areas, today we are at just over 16% of terrestrial land protected, if we include OECMs as well. So the next set of targets were due to be agreed at the UN Biodiversity Conference, the CBD COP15 in October 2020. But in light of the pandemic, it's now been postponed to October 2021. And at this conference, they will review progress over the last 10 years and set out a plan for the post-2020 global biodiversity framework. Not only is it the number of protected areas that is important to reach these goals, but also it's important to know if these protected areas are conserving the natural world in the way that they claim. This monitoring of their effectiveness is where my project comes in, and indeed it's already been a subject of interest in a few studies. We already know some of the benefits of terrestrial protected areas. They include reducing the loss of habitats, especially forest habitat. They increase species abundance and species richness. And they also place sacred sites in legislation, which affords them an extra level of protection. However, what is less known is exactly what characteristics of protected areas are working to achieve these benefits, and this is linked to the lack of studies that link terrestrial protected area characteristics and biodiversity outcomes. Specifically, it's been noted that protected areas too often fail the world's mammals, by not being sufficiently large enough or interconnected enough. My study aims to fill in some of these gaps by looking at specific characteristics of protected areas and the mammal biodiversity within them. So my hypotheses for this study include that the larger, the more complex a border, the more connected, the more natural habitat, both within a protected area and surrounding where a study on biodiversity has taken place, the stricter the IUCN category, combined, all better the outcomes for mammal species richness and abundance. So in order to test these hypotheses, the following datasets have been instrumental. You have the World Database of Protected Areas. This includes variables such as size and IUCN category of protected areas globally. We have the PREDICTS dataset, which is known as Projecting Responses of Ecological Diversity in Changing Terrestrial Systems. And this holds data from published biodiversity site comparisons under different land uses, and it was last updated in 2016. And then we have the Young et al. 2020 dataset, which is a global map of terrestrial habitat types, broken down into a few different categories, which I will show you on the next slide. And then finally, I've used the Digital Observatory for Protected Areas, the DOPA dataset. And this has a number of characteristics specific to protected areas. So I wanted to take you through the methods that I have been doing these past few months. First, I opened the World Database of Protected Areas dataset in GIS, and I filtered only the terrestrial protected areas. Then on top of this, I've put the PREDICTS dataset and filtered it to only include mammals. And then combined, I filtered both of them again to only include PREDICTS sites that fall within protected areas. So on the screen at the moment, you can see all the terrestrial protected areas, and then the little blue diamonds are PREDICTS sites that fall within a protected area. There's more than it appears because some of the sites are close together, so the diamonds just overlap each other. So after I completed this initial set of filtering in GIS, I've then gone to each of the diamonds, so each of the PREDICTS sites, which is a measure of biodiversity of a mammal, and I've set a buffer zone around each diamond of 100 kilometers squared. That buffer zone, so it's just a circle, I've used as a cookie cutter over the Young et al. Dataset, which is that land classification dataset, to give you what has just appeared on the screen. So you can see a few PREDICTS sites in the blue diamonds. You can see the protected area in that light blue colour. And then you have the 100 kilometre buffer around each of those sites. The land classifications of the Young dataset include forest, savanna, shrubland, grassland, wetlands, rocky, desert, and then artificial land. So the reason I use the 100-kilometre buffer is because it was recommended by Miner and Lookingville's study in 2010 on protected area connectivity for mammals. They considered a protected area to be connected if it was within 100 kilometres. So this first site that is on the screen is actually a site in Madagascar, and it's a World Heritage Site. And you can see just how much artificial land is surrounding this protected area. And as a comparison, we're going to take another site in South America. This site has an IUCN category of 6, and in particular this one was looking at bats. And here you can see there's a lot more forest around the protected area, and if I take the protected area away so you can just see what lays underneath it, mostly forest, and right up to that border the artificial land creeps in, leaving that imprint of where it was before. So what I have done for the purposes of my study is I am interested in artificial land, so non-natural land versus natural land. And so I've grouped the young dataset further. So within the artificial land category, that fits into my non-natural land, and it includes arable land, pasture land, urban areas, and plantations. And then for the natural land, I've grouped the variables from forest down to desert as listed on the key. So after working out the land classification around each of the relevant predicts points, importing that into R, I then needed to work on a measure of connectivity between protected areas. And there seems not to be a standard measure in the literature. Different people define connectivity as meaning different things. So what I have defined connectivity as is the distance between protected areas. So to do this, I conducted a near distance analysis in ArcPy between relevant protected areas to my study and all the other terrestrial protected areas. And this let me know the closest protected area to any one of my sites. And then the further variables that I have included are things such as the fractal dimension of all the relevant protected areas. So that looks at things, that looks at border complexity of a protected area. And other variables have included the protected area size, the IUCN category as listed before, the distance from the predict site to the edge of the protected area, the habitat diversity profile, so that is a variable taken from DOPA, the DOPA dataset, which tells you how similar the habitat is within a protected area, or how diverse it is. Another variable is the elevation, and then finally I also included the type of land class at the specific site where the predicts data was taken from. So after finalizing my dataset, having combined all of the datasets that I have shown you before, I then needed to do a correlation matrix just to make sure that none of the variables that I've included were highly correlated with each other. And if they were, then I'd need to think about either maybe excluding them if that was relevant, or adjusting them if that was appropriate. So after completing the correlation matrix to investigate the collinearity of my input variables, listed on the left here, I realised that there was an issue with the collinearity of the predominion, and that is the land classification of the exact site where the predicts data had been sampled. And there was also another issue with the IUCN categories. For my data, I'm usually comfortable with a variance inflation factor of about 5. But as you can see here, the IUCN category has variance inflation factor of over 200 and the predominions 24. So both of these were an issue. Because both of these variables are actually categorical, I decided to further group them to see if this helped with the collinearity. So the IUCN categories, IA to II, I class these as strictly managed sites, and then IUCN categories 3 to 6, I've classed these as the least strict managed sites, as these are the areas that more human activity is allowed. And then for the land categories for the predict sites, I've grouped them similar to what I did with the Zhang et al. 2020 data with that natural and non-natural land. And then I have rerun the correlation matrix, and we can see on the right, it worked. So all of the variance inflation factors are now below 5, so I was a lot happier with that. And this means that I am now ready to begin exploring the best way to analyse my final data set, and that is where I am right now. So the results are to be confirmed. Watch this space. So my future chapters, I will be using them to explore deeper the role of protected areas on our planet's biodiversity, especially in the face of anthropogenic and climate change pressures. And if you'd like to follow my progress, please feel free to follow me on Twitter or my YouTube channel. And I'd just like to thank you for your time in listening to my talk. If you have any questions for me, please send them into my email address and I will answer them as soon as possible. Thank you very much.